Hey everyone, Mr. Newman here, and today we're going to learn do just a practice example quiz on 6.1 substitution, solving linear systems. So let's get started. First of all, we are going to use substitution for all three of those. Yes, you can solve these using elimination, but they're actually all set up to be much faster with substitution. And on each of these, you notice that with the exception of the third one, we already have a variable by itself. So for number 1, y is by itself. So I'm going to put the 6x minus 11. So I'm going to substitute that in for y since it's equal to y. So let's rewrite that equation. And instead of the y, I'm going to put in 6x minus 11. Now we just distribute the negative 3. You get negative 2x minus 18. Negative 3 times negative 11 is positive 33. And then we combine like terms, and we solve for the variable. So I'm going to get x by itself by subtracting 33, then dividing negative 20, and we get x equals 2. Now to get y, I can plug that into either equation, but I'm going to choose the top one since it's already solved for y. And if I plug that 2 into there, I get 12 minus 11, which is 1. So my solution is 2, 1. For number 2, again, we already have a variable solved. So x is by itself, which means I'm going to put that negative 1/3 y plus 3 in for x because it's equal to x. Now I just need to distribute the negative 3. Negative 3 times negative 1/3. Well, 3 times a third is 1, and a negative times a negative is a positive. So we get positive y minus 9, because negative 3 times 3 is negative 9. And the rest of the equation falls out like that. Now we need to combine like terms. Y and negative 5y are going to combine to become negative 4y. And the minus 9 is also there, and that is equal to 15. Let's now solve for the variable. Now that we have y, let's get x. Again, I'm going to use the equation that is already solved for x if I want to figure out what x is. So I'm just going to plug it in. Plug in negative 6, substitute that in for y. And we get 1/3 of 6 is 2, and a negative times a negative is a positive. So we get 2 plus 3, which is 5. So my solution is 5, negative 6. For the third problem, I don't have a variable by itself, but I have a few choices. I'm going to choose to get the the y by itself down here. I could have done the x by itself instead, but I think that if you were to do that, you'd have to deal more with the fraction. I know a lot of us aren't fans of fractions, so I'm going to try to deal with it as little as possible. So I'm going to solve for that y. And now that I solve for that, I'm going to substitute the negative 2x plus 6 in for the y on that first equation. Notice I have the parentheses there in place of y, and I'm going to put negative 2x plus 6 right there. Now we just need to distribute the 1/2. Well, half of negative 2 is negative 1, and half of 6 is 3. See, that wasn't so bad, the fraction there. Positive x plus negative 1x adds up to 0, so we get 3 equals 3. Notice there's no x's here. We've eliminated the variables. There's no y's. Yet, we didn't get any more information, and 3 equals 3 is true, so we know that is there are an infinite number of solutions. You can just write infinite solutions. For 6.2, solving linear systems. For each of these, we're going to use elimination to solve them. Remember that elimination is when you combine or add up the two different equations, and you eliminate one of the variables when you add them together. That way you can solve for one of the variables, and then you can plug it back in. So let's get started here. Let's add up each of the variables, kind of in columns here. So 4x plus 3x is 7x. The negative 4 and the positive 4 add up to 0, so I'm just going to cross those out here very lightly because I need to be able to see that for later. And 20 plus 8 is 28. Now we solve for x by dividing by 7. X is 4, and I'm going to substitute that back in. I'm going to go ahead and use the lower one because it's all positive and there's smaller numbers. that really doesn't matter. You can use either one. I'm going to plug the 4 in for x. That's 12 plus 4y equals 8. And when I solve for y, I get negative 1. So my point is 4, comma, negative 1. For this one, in order to eliminate, I really need to multiply one of the equations by some number. I could multiply the top by negative 3, but that would make that negative 14 a really big number, and I like dealing with smaller numbers. I chose to multiply by negative 2 because of this right here. See how there's 2y and positive 1y? If you multiply the bottom by negative 2, then those two will add up to 0. So let's do it, and I'll show you how that happens. So I'm going to write that down right underneath it. The top one I'm going to copy down just so I can add them into columns. So we add negative 6x and x, we get negative 5. Okay, this right here, you guys, this is why I multiplied by negative 2, because I saw, oh, I can eliminate the y's that way. They add up to 0, and they're equal to negative 20. Now I just solve for x. And we have x equals 4. To solve for y, or to figure out y, we're going to have to plug into one of the equations. I'm just going to take this bottom equation, I rewrote it over there, because y is already sort of by itself, and I think it'll be a little bit easier, but you could have also used the top equation. Let's put the 4 in for x, because 4 is equal to x, and now we solve for y. Subtract 12 from both sides, and you get y equals negative 9. So our solution is 4, comma, negative 9. For the third problem here, notice there are no variables that line up nicely, so I'm going to have to multiply something by something here. Let's multiply the top by negative 2. That way that x, negative 2x, will eliminate with the positive 2x. And when I do that, I want to rewrite it. I can just rewrite it right underneath there. That way I can have them lined up. And when I add these up, 2x and negative 2x add up to 0. But negative 10y and 10y also add up to 0. Now I need to write something on the left. I can't just leave it blank. So I'm going to put 0 equals negative 20 and negative 30 combined to become negative 50. And is 0 equal to negative 50? Well, no, it's not equal. They're not anywhere near the same thing. So then since that is false, we have a situation where there are no possible solutions. No solutions.